Good day to you. My name is Troy Patrick Malvar, and I will be discussing about VOR. What is VOR? Some brief history about VOR, applications of VOR, uh, advantages and disadvantages of VOR, and many more. Now let's proceed to the video. I would now discuss about VOR. What is VOR? VOR stands for VHF Omnidirectional Range. Some brief history about VOR. VOR is derived from the old four-course radio range from the late 1920s and 1930s. Throughout the 1920s, commercial aviation was hampered by the need to fly only in fair weather, when aircraft could navigate by visual references on the ground, a technique called pilotage, or by risky assumptions based on compass, airspeed, and clock as indications, and reported winds, combined, calculated, and plotted on a map, a technique called dead reckoning. Radio navigation technology emerged by the late 1920s, allowing fairly precise navigation without reference to the ground, nor the optimistic and daring trust in dead reckoning. VOR gained widespread use for the navigation in the 1950s, made instrument navigation a commonplace. VOR are commonly described as broadcasting 360 separate radios emanation from the station in all directions. This is basically used to determine the position of the pilot to or from the station. Radios are terms for radio signals sent by the radio station, which is on the ground. By the way, VOR has reference through the magnetic north. VOR is basically a type of short-range radio navigation system for aircraft. The signals are line of sight between the transmitter and the receiver, useful up to 200 miles. VOR operates at 108 to 117.5 MHz frequency range. The first 4 MHz is shared with the Instrument Landing System or the ILS band. To leave channels for ILS in the range 108 MHz to 111.95 MHz, the 100 kHz digit is always even. So 108, 108.5, 108.20, and 108.25 and so on are VOR frequencies, but 108.1, 108.15, 108.30, 108.35 and so on are reserved for the ILS in the US. I will now discuss about the types of VOR. As you can see in the figure, there are three main types of the VOR, which is the high altitude, the terminal, and the low altitude. There is a note on the picture saying all elevation zone are with respect to the site elevation, which is the AGL. First, terminal is from 1,000 feet above the ground level up to and including 12,000 feet AGL at radial distances out to 25 nm. For the low altitude, from 1,000 feet AGL up to and including 18,000 feet AGL at radial distance out to 40 nm. And for the high altitude, there are 4 categories: the 1,000 feet to 14,500 feet, out to 40 nm, 14,500 to 18,500 feet, out to 100 nm, 18,000 to 45,000 feet, out to 130 nm, 45,000 feet to 60,000 feet, out to 100 nm. So the basic principle of VOR is that the radial is with respect to the magnetic true north of the Earth. The VOR receiver gives one LOP called a radial. So radial is also called LOP in the VOR navigation system. I will now discuss about the parts of VOR system. As you can see, there are four main parts of the VOR system in the figure. A stance is referring to rotating course card. It is calibrated from 0 to 360 degrees. It indicates VOR bearing chosen as the reference to fly to or from. The B is the Omni Bearing Selector or the OBS knob. It manually rotates the course card. The C stands for the CDI or Course Deviation Indicator. It swings left to right. When the needle is to the left, turn left, and when the needle is to the right, turn right. When centered, the aircraft is on course. Each dot in the arc under the needle represents a 2 degrees deviation from the desired course. For letter D, it is the to from indicator, meaning if the arrow is pointing up, you are flying to the VOR station. If the arrow is pointing down, you are flying from the VOR station. It changes to red flag if the VOR is beyond reception range. Here are some other parts of the VOR system: the glide slope indicator, the knob warning flag, the course selected, and the reciprocal of the course selected, and the basic of all is the heading. I will discuss an example for reading the VOR system. As you can see in the figure, from the VOR system, it is pointing to 345 degrees radial, and the indicator is pointing down, which means that the aircraft is flying away from the station. Another example is, for this figure, almost the same scenario, but as you can see, the to from indicator is pointing up, which it means that the aircraft is flying towards the station. Here are some techniques in flying the VOR or using the VOR when you are in the aircraft. Initial tracking. You need to tune, identify, and twist. Turn the OBS to the center needle and figure out position. Note that the heading on top of the card is the rotating course card. Then, you should also consider into the factor is the wind correction. Further away, more correction is needed to get back on track. Generally, when within 20 nm, 20 to 30 degrees in direction of needle works. And station passage. CDI would be very sensitive and then begin to oscillate. So intercepting. If needle is alive, then turn towards it as if you were tracking it. If full deflection, first center needle to find what radial are you on. Twist OBS back to the desired course, parallel that course, and then turn 30 to 60 in direction of needle depending on the distance from the station. In the figure, I will show you a VOR transmitter system. For approach navigation, it uses frequency 108 to 112 MHz. For short-range navigation, it uses 112 to 118 MHz. Two channels are emitted at the same time with the following characteristics. For the reference phase signal, it is designated as symbol R. The modulation used is frequency modulation, and the rate of change is 30 Hz, and it is non-directional. For the variable phase signal, it is designated as symbol V, and the modulation used is amplitude modulation. The rate is 30 revolutions per second, or it is equal to 30 Hz, and it is rotational. VOR transmitter sends a Morse ID code to the VOR receiver, which is the aircraft. So the VOR transmitter is also used for two-way voice communication. In this figure, I will now show you what the typical receiver system looks like for VOR. From the figure, we can see an AM detector, filters, the limiter eliminates the noise, frequency discriminator, then it will go back to the another filter, then it will compare to outputs, and it will now be at the output. Frequency of operation is, of course, very high frequency. The phase difference between R and V is calculated, which can be seen from the output of the phase comparator. Aircraft course deviation indicator shows the VOR radial reading. If CDI becomes defective, a red flag will appear on the VOR system. Distance measuring equipment. It uses radio signals sent out from the aircraft to the ground station. Ground station interprets the signal and sends back. Equipment in the aircraft measures time and convert to nautical miles. Nautical miles is equivalent to NM. DME ground station is part of ATACAN. ATACAN is a military navigation system which adds DME to a VOR station. A VOR with DME is known as vortex station. I will now discuss some applications of VOR. VRway, used to assign highways in the sky. Track intercept, to be able to get back to the track due to crosswind. Simply fly toward the needle of the VOR display, as I discussed earlier, known as the course deviation indicator, to ensure that the aircraft is going in the direction of the VOR ground station. Triangulation position fix. To know where the aircraft is located, tune VOR receiver to at least 2 VOR ground station and obtain 2D position fix. So this method can be used if you are near 2 VOR ground stations. So this is an example of the VRways, the highways in the sky. So this is what the tracking intercept looks like. Then I will now discuss the disadvantages of using VOR. First off, error is approximately about positive to negative 2 degrees. It is limited to line of sight because of its frequency band operation, which is the VHF. VOR signals are either reflected or blocked or distorted due to buildings, mountains, fences, power lines, and etc. So, which means that it is almost similar to a microwave system. At higher altitude, interference may occur between 2 ground stations operated at the same frequency. VOR does not provide the aircraft heading, it only points to the ground station. Now, this is the end of my infographic video about the VOR. Thank you for watching my video about VOR. I hope you learned something about VOR. Thank you for watching again.